next unit we're going to begin covering is about scatter plots and trend lines. So this is the first day in a series of 3 where we discuss scatter plots and trend lines. So some vocabulary terms you need to get into your notes. A scatter plot is a graph with points that are plotted to show a possible relationship between 2 sets of data. Correlation describes the relationship between the 2 data sets. And there are 3 types of correlations we discuss. A positive correlation, which is when both sets of data values increase. And as you can see from the graph, if you were to kind of draw a best fit line through here, you'll see that the slope of that line would be increasing or positive. A negative correlation is when one set of the data values increases but the other set decreases. And again, if we were to draw a line of best fit through this data, you would see that the slope here is negative. Then we also have no correlation, and that's when there's no relationship at all between the 2 data sets. And a trend line, or a line of best fit, it's a straight line that's drawn through the data of a scatter plot to help show a correlation. And I do want you to make sure that you have all of this in your notebooks, including the 3 different correlations and a quick sketch of what all 3 of those look like. So we're going to look at some examples of scatter plots. So the table shows the number of cookies in a jar from the time since they were baked, and you're asked to graph a scatter plot using the given data. So we're going to use the chart and then the scatter plot that I've already started on the right hand side. So go ahead and take a few moments, pause the video to copy the graph down and also the chart. And once you're ready to start graphing the points, you can go ahead and resume the video. So, in the first day, there are 24 cookies, so we're going to plot 1, 24. Second day, there are 16 cookies. The third day, we have 10 cookies. And on the fourth day, there are 7 cookies. So you can see that it's not a linear relationship. And really, to get a good indication of a scatter plot, we like to have several points. But you can still see here that this would be a negative correlation, because as the days increase, the number of cookies decrease. So you have one set of the data, the days, increasing, and you have the second set of the data, the cookies, decreasing. So here's another example. The football team scores for the first 4 games. So this is what the team has scored during the first 4 games. And when you make a scatter plot, if you noticed on the other example, we always want to make sure that our axes are labeled. Typically we put time across the bottom, and in this case this would be number of games. One, 2, 3, and 4. Kind of squeeze those numbers in there. And then also we have a score. Notice the scores go anywhere from 6 up to 46. We'll make that mark 50. 10, 20, 30, 40. And the label here could be points scored. So again, the first game it was 6 points. The second game, 21. The third game was 46. And the fourth game was 34. Oops, first one went away. And a scatter plot, if you think about its name, is literally just data points that are plotted, and they're kind of scattered. They don't make a straight line or any parabola, U-shape, or V-shaped curve or graph. So now we're just going to look at the data and describe the correlation. So you don't need to write these into your notes, but just watch and follow along the video as we go through these. So for example 3, the graph is regarding beach visitors, and it says the average daily temperature versus the number of visitors at the beach. So you can see that the temperature is increasing across the bottom of the graph, and then you can see that the number of visitors increases as you go up the side of the graph. Oops. So the question here is the correlation positive, negative, or zero, or no correlation. And hopefully what you're recognizing is that as the temperature is increasing, so are the number of visitors. So this one would be a positive correlation. In this next example, we're looking at a snowboarding competition. So we have the years across the bottom and the numbers of participants going up on the y-axis. So again, as you look through the data and through the scatter plot, you can kind of see an increasing trend as we go through the graph. So what's happening is as the years go by, there are more and more participants in the snowboarding competition, and you can attribute that to several things. Some suggestions in the past have been that maybe snowboarding has become more popular due to like internet or YouTube sensations. You're able to follow people who are really good snowboarders, which again makes the sport more popular. But in any rate, this is a positive, again, a positive correlation. And remember, you can draw that line of best fit or that trend line through the data. And the trend line, again, remember, should connect a couple points on the graph. And if it doesn't connect a couple points, it should at least be, it should at least be in the middle of the scatter plot. So now we're just going to look at some explanations, some statements, and I would like you to write these into your notes. So if you want to take a minute or two to pause the video and write down 5 and 6 into your notes, and then as we talk about them, writing down the answers. So you're asked to identify the correlation that you would expect to see between each pair of data sets, and then also explain. So the average temperature in a city and the number of speeding tickets that are given in the city. So if you think about what happens as the temperature goes up, what happens to weather, what happens with road conditions, or if you think about when the temperature is decreasing or going down, it's colder, what's happening to the number of even cars on the road, or the number of, the road conditions. And so, in my opinion, as the temperature goes up, this number of speeding tickets probably also goes up. And again, if you think about it around here, for example, a perfect example is today's e-learning day. Probably not a lot of speeding tickets given today because the road conditions are so poor that if you're a good driver, you are not speeding. So this, I would say, is a positive correlation. And I'm not going to write down that long explanation that I just discussed, but in your homework, if it does ask you to explain, then I do expect some sort of explanation. So number 6 is the number of people in an audience and the ticket sales. And hopefully, for this one, we recognize that the more people there are in the audience, the higher the ticket sales are, because each of those people has to purchase a ticket. So this would also be a positive correlation. So again, the more people in the audience, the greater the ticket sales, the more money they make off of tickets. The fewer people in the audience, the lower or the less amount they make from tickets. I believe these are the last 2 examples. So again, identify the correlation that you expect to see and then explain. So we have, again, write these down. The runner's time and the distance to the finish line. So we're thinking about someone running a race, and as the time that they've been in the race increases, our assumption here would be that they're getting closer to the finish line. So as the time increases, the distance to the finish line would decrease. So that would be a negative correlation. And sure, you could argue some silly things like maybe they're running in the wrong direction, but typically we're not doing those crazy what-if cases. So the runner starts the race, the longer they run, the closer they get to the finish line, so their time is going up, their distance is going down. That's a negative correlation. And for example 8, we're discussing the temperature in Houston and the number of cars sold in Boston. So as the temperature goes up or down in Houston, what's happening to the number of cars that are sold in Boston? And hopefully you're recognizing that this is no correlation. It'd be really difficult to try to connect those two situations, since to start with we're not even in the same city or the same state even. So no correlation between the temperature in Houston and the number of cars that are sold in Boston. Oh, a couple of examples here now where you are given a situation and asked to find the scatter plot that best represents that relationship. So here we have scatter plots that are discussing the age of a car and how much it's spent, how much money is spent on repairs. And so if you think about that just in your head for a moment, you've got cars, they're getting older. Are you spending more money on repairs or less money on repairs? Typically, the older a car is, the more money you're going to spend on repairs. So if we look at those three graphs, I see two that look like positive correlation and one that looks like a negative correlation. I'm going to go ahead and rule out graph C because I know that as the car gets older, you're going to be spending more money, and this graph indicates that you're spending less. So it's not graph C. Now we look at A and B. If we draw our trend line through quickly, you can see positive correlations in both cases. However, we're talking about age of a car, and it's very difficult for age to be negative. Age is never negative, so that also rules out graph A. So we're looking here at graph B. The older the car gets, the more costly the repairs are. That's a positive correlation, and that scatter plot best represents that relationship. For this example, if you would like to just write down the graph, copy down graph B, or you can copy down all three of them. Scatter plots are also helpful because you can use a scatter plot to help predict what might happen in the future. So here you can see we have concession stand sales where we have the number of tickets are sold and how much money the concessions make. So again, this is a case of positive correlation, which you should expect because as more tickets are sold, more people are there to purchase those concessions, so your sales also go up. So number 10 says that the scatter plot shows a relationship between the total amount of money collected at the concession stand and the total number of tickets sold at a movie theater. So based on this relationship, predict how much money will be collected at the concession stand when 150 tickets have been sold, and use the trend line to make your prediction. So this is what trend lines or lines of best fit are really good for, helping you make predictions. So we're looking for what happens way out at 150 tickets. And 150 tickets, it looks like these go by 20, 40, 60, 80, 100, 120, 140, 160. So 150 would be right in here, there, and you're looking where the graph hits the line, and then you want to take it over to the Y from that same place. And so if this goes 2, 3, 4, 5, 6, 7, we're at about $750. So something close to that for your prediction, about $750 would be made in concession stand sales if 150 tickets are sold. When we return to school from the e-learning day, we do still have to take our Pythagorean theorem test, so that's going to be first. And then you were to have done a study island yesterday for e-learning over scatter plots. I will be checking this video to make sure that the notes are in your notebook, and we'll work on the worksheet on the day the next day we're back at school following the Pythagorean theorem test. So good luck and enjoy your day off.